Distance on the coordinate plane, lesson 5.7. Standard is 8G8 and 8EE2. The objective is to find the distance between 2 points on the coordinate plane. The essential question is, how can algebraic concepts be applied to geometry? Let's go over the steps. Step number 1. Plot the points. Step 2. Create a right triangle. Step 3. Plug the triangle's side lengths into the Pythagorean theorem and solve. So remember, the x is telling us how far sideways. So when we go to the left, that means it's going to be negative. When we go to the right, that's going to be positive. Now the y value tells us how far up and down. So when we go up, it's going to be positive, and when we go down, it's going to be negative. Example number 1. Find the distance between 4, -2 and -5, 6 on the coordinate plane using the Pythagorean theorem. So first I'm going to plot 4, -2. I'm going to start at the origin and go to the right 4. 1, 2, 3, 4, down 2. 1, 2. Now I'm going to plot -5, 6. I'm going to start at the origin again, go to the left 5. 1, 2, 3, 4, 5, up 6. 1, 2, 3, 4, 5, 6. Now I'm going to connect my dots. And I'm going to connect the last line. And if you notice, it forms a right triangle. So I'm going to go ahead and count my squares now so I can find the lengths. So from the right triangle to the end, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. And from the right triangle going up is 1, 2, 3, 4, 5, 6, 7, 8 boxes. So I noticed that 8 is the smaller side, so that's going to be side A. And 9 is the medium side, so it's going to be side B. And across from the right triangle is going to be side C. So now I'm going to go ahead and write the formula for the Pythagorean theorem, which is a squared plus b squared equals c squared. So a squared is going to be 8 squared. B squared is going to be 9 squared. And then bring down c squared. So 8 squared is 64. 9 squared is going to be 81. Bring down c squared. So 64 plus 81 gives me 145. And bring down c squared. Now I need to take the square root of both sides. The square root of c squared is just going to be c. The square root of 145 is approximately 12.04. So that means the answer is approximately 12.0 units. Example 2. There is another way to find the distance between 4, -2 and -5, 6 without drawing a triangle on a coordinate plane. For any right triangle, a squared plus b squared equals c squared. If we solve for c, the square root of c squared equals the square root of a squared plus b squared. Therefore, c equals the square root of a squared plus b squared. So the distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So I'm going to start by rewriting my points. I have 4, -2, and -5, 6. I'm going to label them. I have x sub 1, y sub 1, x sub 2, y sub 2. Now I'm going to write the distance formula. D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now I'm going to go ahead and plug in my points into my formula. So I have x sub 2, which is negative 5, minus x sub 1 is 4 squared. Then I'm going to add y sub 2, which is 6, minus y sub 1, which is negative 2 squared. That's all over the square root. So negative 5 and negative 4, that's going to be a negative 9 squared, plus I have a negative, and times a negative, that gives me a positive. So 6 plus 2 is going to give me 8 squared. That's all over the square root. And then I have negative 9 squared, that's going to give me 81. Plus 8 squared is 64. All over the square root. When I add those together, 81 plus 64 will give me the square root of 145. When I take the square root of 145, that's approximately 12.0 units. So you have two different ways on how to solve for the distance, so you choose whichever way is easier for you.